Okay, so hello everyone. This is the start. This is the start of a lecture series that aims to introduce you to algebraic Julia or just Julia, which is a programming language that is used for symbolic math computation. And the advantage of Julia is that it's a high level language that has the performance of C and the speed and performance of C. And so it is widely used for very good mathematical modeling, and that is our aim with this course, to use Julia and to learn how to make advanced math models that do not require as much as much code as things in as the same equivalent in Python or C. So with that, first, today's video is going to cover very few things. We're going to just talk about installation. Then we're going to talk about very basic things like for loops, arrays, dictionaries, and just initialization of variables, and for loops. And what else? Yeah, and then we're also going to introduce you to types or data types, which is a algebraic Julia was built using applied category theory. So things like types, and categories, and like functors, stuff like that is going to be our aim. So we aim to build up to those concepts, and this will be just a little start of that concept. Along with that, in the end, we will have an assignment for just a very basic program for Euclid's algorithm to find the GCD of any two integers. So with that, let's start. What I've opened here is a YouTube video. So over here is just if you search COLAB and Julia, then you'd find this video. It's a 2-minute long video, just a very short explanation of how to run Julia on Google COLAB, because that is much more easier. At least I feel. I've always had trouble with installing languages and and packages and etc. So I was already comfortable in Google COLAB. So when you click on their notebook link, you want to do so in this template. There's all these different things about just things you could try to check if Julia is working on your thing. So what you want to do, I'll explain what you got to do. First, you have to run this code cell. And after that runs, what you're going to do is you're going to change the runtime type. So that changes your entire COLAB notebook from running in just Python to Julia. And that's when you can actually start coding. Because if you don't do that, then any Julia program you write will just give you a error, syntax error. So over here you see it's already selected runtime type as Julia, but typically it would be selected as Python 3. So all I gotta do is I gotta click on this, alright, and I gotta click on change runtime, or I can click on runtime over here and I can click on change runtime type. So you click on that, select Julia. This depends on later. We don't really need to care about what type of hardware we're using. So for now, CPU will do just fine. So once that's installed, these are all Julia commands. In this notebook that's linked in this YouTube video, you can just, check your version. Okay, yes, there we go. So when we run our version info, this just fetches just whatever version is installed. For the installation part over here, like you just open the template, install this, and then from down here you can just do whatever you like, just add a new code and just type whatever you need. So for that, I have a notebook ready. Yes. So this is the notebook we'll be using for the duration of the course. Okay. And here we have the installation thing. So right after the installation thing, I just deleted everything, and now we started the actual programming, learning how to code in Julia. So the first thing we will do is we'll start with very basic stuff. In this line, we are initializing a variable x and we're assigning it a value of 10. And as expected, it prints out a value of 10. So what I expect is if you want to actually understand what's going on, it's best to try and follow along, type x is equal to 10, x is equal to 23, and just do it and get familiar. Then over here we're defining another value, g, such that it is this expression in terms of x. Now x is already defined over here, so you can grab the value of x from there and it'll just plug it in this thing, give you the value of g. Now Julia is based on was built using applied category theory, right? So naturally there's a very math focused approach to everything. We naturally have things like vectors over here, and then dictionaries, stuff like that. So these are some basic ones, but we will eventually go into more abstract stuff. So a vector, you just define it as array of elements. Say this is the vector of 5 prime elements. So you what do you say, initialize your vector like this, square brackets 1 2 3 4 5 7 11. And one thing to note is key in typical languages. Let me just put a comma over here. Okay, so the indexing is different in this thing, Julia. So typically we would start with v0, v1, v2, all the way to I think this is 5, right? So the last index would be 4. So this was our normal kind of notation. In Julia, it is not like this. Instead of starting at 0, we start at 1. So that is one difference that you'll find. One of the smaller differences that you'll find. Just something to take note about. That's why over here, when I click on V1, it outputs the first element, that is 2. Similarly, for loops are also pretty much the same. If you're used to programming, then nothing special is going on over here. You define an initial variable total equal to 0 for every element in the vector. Here, incrementing the total, or you're summing the total. So this total gives you the sum of all the elements in the list. So when I run this, it should give me 28. So yeah, 2 plus 3 plus 5 plus 7 plus 8. That is 18 plus 10. Yeah, 28. Okay. So, and then lastly, we have functions. So functions are, the good thing about Julia is that functions are just, defined pretty like symbolically. So you can get used and get comfortable to the kind of notation that's over here. So over here, what I mentioned about, functions or like applied category theory and types, data types being a whole big deal, comes into play over here. So in here, instead of taking a variable x, we take a data type n, such that n belongs to integers. So f is a map from integers to integers, or at least f takes a number n that belongs to integers for now. If you understand it that way, that's good. So we just perform this operation, n squared plus 1 end. Okay, close the function with an end. And similarly, we define another function g that is going from r squared to r, right? Similarly, this time we're using a different initialization to show the two different ways that you can define your functions. So there's one way where you can explicitly say what data type you're taking in. There's another way where you can only define, where you can only explain which, variables you're taking in, right? So yeah, you're defining the function g, and you're gonna return root of g. So you're taking a 2D element and you're converting it to a scalar. That is x squared plus y squared. You return that value and okay. And so if you run this, just go with KL for now. And we'll replace this with KL. Yes, there you go. So yeah, pretty simple, pretty straightforward. The only aim of today's video was to just go over very basic stuff and to show you how to install. So installation, I am never really big on installing languages on my laptop, so I've just preferred to do it on COLAB because I'm comfortable on COLAB. And yeah, so this is your homework assignment. Yeah, the question is given here and the code is given here. So yeah, we have GCD. I'll explain the question before I end the video.